Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will discuss you the projectile motion projection at an angle from the ground. Now suppose this is a ground. Now a body at here is projected at an angle theta with the ground with velocity u. Okay. Now the component of this velocity along horizontal direction will be u cos theta, and along vertical direction this is u sin theta. When it goes upward, the velocity initial as the acceleration due to gravity acts vertical direction. So when the body goes upward, then the velocity decreases gradually, so it becomes this here. Now at here this, and final velocity vertical direction here 0. But along horizontal direction there is no component of acceleration due to gravity, so here g equal to 0. Along horizontal direction there is no acceleration, so the velocity along horizontal direction remain same at all points. So here u cos theta, here also u cos theta, here u cos theta, here u cos theta, u cos theta, u cos theta, u cos theta. That is one important point, is that the horizontal velocity at any point of the projectile path is 0. Projectile path remain constant, which is u cos theta. So along this direction there is no component of acceleration due to gravity, so velocity remain constant, always remain same. This. Now along vertical direction what happens? Acceleration due to gravity acts vertically downward. This is opposite direction of velocity, so the velocity gradually decreases. This is less than this is less than this, and finally at here vertical component will be 0. Now along same level this velocity and this velocity is same, because along same horizontal level the upward velocity and downward velocity remain same. I have discussed earlier in previous class. So along same horizontal level upward velocity and downward velocity remain same, so this becomes this and this equal, this and this equal. So now we have to find the maximum height, range and time of flight, etc. for this projection. Here, this is x direction and this is y direction. So we take velocity along x direction, acceleration along x direction, and velocity along y direction and acceleration along y direction. Velocity along x direction, we take this velocity along x direction equal to u cos theta, and acceleration along x direction is 0. Velocity along y direction gradually decreases, this is variable, and acceleration along y direction is minus g and magnitude is g. Velocity along y direction is different at different time. So to find the time of flight, t equal to 2 Vy by Ay. We take this time of flight because along y direction vertical velocity 0, so if we take v equal to u minus ay into t, So we get time taken to reach at the maximum height from this ground, time taken to reach from the ground to the maximum height equal to t. So here final velocity becomes 0. So this becomes 0. Uy becomes 2 sin theta. Ay becomes g into t. So t equal to u sin theta by g. So time of flight t, this will be twice t, that is 2 u sin theta by g, which is equal to, we can written this 2 of initial velocity by a y in this form. So time of flight, the formula of this can be written in this form, and for that case we remember the formula of time of flight, this 2 u sin theta by g. This formula is more convenient when we apply the projectile motion along inclined plane. Okay, so we remember in this form, and also for that case we remember the time of flight is this. Now to find the range, is, suppose this is point A, this is point B, so this is the range, this is the range. So range equal to, we know along this direction there is no acceleration, so range equal to velocity, this is distance equal to velocity into time, velocity will be this into time, this time of flight. U square, u into u square, 2 sin theta cos theta is sin 2 theta by g. So range equal to, we can write in this form, ux, velocity along x direction, into time of flight, which is equal to 2 uy by ay in this form. So for that case we remember this formula, and also in this form, this is common formula when we apply at any position. Suppose when we want to project a particle from an inclined plane, then we can apply this, but for that case we remember this formula or this formula. Maximum height, so for that case we use h. Now maximum height we consider the motion in vertical direction, because height is along vertical direction. So Vy equal to 0 for maximum height, Uy equal to u sin theta minus 2, this is g, and h is h maximum. So h maximum here, which can be written as u sin theta means u y whole square by 2ay. So maximum height equal to this formula, and for general we can write this formula. Now condition for maximum range. Range equal to u cos theta into time of flight u square into 2 sin theta cos theta is sin 2 theta. So range is maximum when sin 2 theta, maximum value of sin 2 theta 1. So range is maximum when sin 2 theta equal to 1, that is 1 is sin 90 degree. Okay, so theta equal to 45 degree. So when we project any object at an angle 45 degree, the range is maximum. Now for particular two angle, the range will be same, because range equal to formula u square sine 2 theta by g. Now if we take the angle theta and 90 minus theta, then what comes? So at angle theta range is this, but at angle this, what is the range? Range will be g equal to sine 180 minus theta sine 180 minus theta equal to sine theta, sorry. So this equal to e square sine 180 minus 2 theta by g. So this equal to, because sine 180 minus theta equal to sine theta. So this and this same. So particular two angle theta 90 minus theta, range will be. So at angle theta, range equal to e square sine 2 theta by g, and maximum height, suppose h1 for that case, equal to u sine theta whole square by 2g. Now at angle theta equal to 90 minus theta, at angle theta, at angle 90 minus theta, at angle 90 minus theta, what is the maximum height? Maximum height equal to u sine whole square by 2g. So this will be u square cos square theta by 2g. Now range will be same. Range will be same because it is this. It has already discussed in previous. So range same, but maximum height can be different. Okay, maximum height can be different. So if we multiply this and this, if we multiply this and this, if we multiply h1 into h2, this is maximum. What happens? This is so u sin theta cos theta u square g square u square. If we multiply 4, here 4 and this 4, so this equal to 2 sin theta cos theta whole square by 4 g square. So u square sin square 2 theta by g square, which is equal to u sin 2 theta by g whole square, that is range r square by 4. So we got a result r square equal to, so we got a result r square equal to 4 into h1 h2. This formula is important to solve the MCQ problem. So if h1 h2 be the maximum height attained at an angle theta and 90 minus theta, at an angle, if h1 h2 be the maximum height attained by two angles, by two specific angle, for that range are same, then the condition, the relation between h1 h2 and r will be this: at any time t after projection, next topic is velocity at any time after projection. Suppose the velocity is projected at here at angle theta, and we want to calculate the velocity at that point. At that point, here, at that point, this is velocity v. So this angle is, suppose take alpha. Now there are two components, vx and vy. So what will be the vx? Vx, the horizontal component remains same throughout the motion. So vx will be u cos theta, and vy equal to u sin theta minus g into t. V equal to u minus gt formula. V equal to u minus gt formula. So vy equal to we take y, g means ay into t. So from that equation we get the result this. So now velocity v will be this, if this direction is I and this direction unit vector is j, so we can write v equal to this. So magnitude of v equal to vx. So magnitude of this equal to this. Now vx equal to this. Next topic is velocity at any height from ground. Now we want to calculate this height. Suppose this is h. This height different. Suppose we want to calculate the height h after projection and that velocity. So we do here time is not given, here height is given. So in terms of height we have to calculate the velocity. So again we v equal to, we know vx square plus vy square, vx equal to this remains same, but now velocity we retain. Now velocity we write in terms of h, that is so v square equal to this. Now v equal to root over this. This is in terms of height. Velocity at any angle alpha with horizontal. Suppose this angle, all are different. Suppose this is beta. This angle, all are different. Suppose we are giving a angle alpha with horizontal, then at that angle what is the velocity? Suppose at here. Now take the velocity v. So if the velocity becomes v, then horizontal component will be v cos alpha, vx equal to v cos alpha. Now we know the horizontal component remains same, so v cos alpha equal to u cos theta. So from that v equal to u cos theta by cos alpha. So this is a result. This is velocity at any angle alpha with horizontal. Next topic is find the angle of particle with horizontal after time t. Suppose this. Here we want to calculate this angle. Alpha is not given. We calculate the time t. Now we know tan alpha equal to Vy by Vx. From this result, Vy, this is Vx. So Vy equal to u cos theta. So from that alpha, we get the alpha from this relation. What is the angle between velocity and acceleration at highest point? At highest point means this. So this is the direction of velocity, and velocity only this, and acceleration along this. So the result is 90 degree. So answer will be 90 degree. What is the velocity at highest point? Students generally say that velocity becomes 0 at highest point. Velocity is 0. But velocity is u cos theta, because velocity vertical component is 0, but horizontal component remains same. So the velocity at highest point becomes u cos theta. Change of momentum when particle strike the ground. Change of momentum. Now change of momentum, we know change of momentum del P, vector quantity m v minus u. This is the change of momentum formula. Final velocity, initial velocity. Now what becomes final velocity? Velocity along this direction so this is the velocity, final velocity u at here, and this angle also remains same, theta. So this is unit vector I, along this is j. So final velocity becomes, in terms of vector quantity, u cos theta I minus u sin theta j. Why? Because we take j in this direction. So in this direction, unit vector will be minus j minus initial velocity minus u cos theta I plus j. So what comes the result? This and this cancel, this and this cancel. The result is minus 2m u sin theta j. Change of momentum will be this. The magnitude of change of momentum equal to this. This is the result. This is the result. Particle of mass 2 kg is projected at an angle 60 degree with horizontal. Find the velocity at maximum height, velocity after 1 second, projected at 60 degree with horizontal, with velocity 80 meter per second, velocity at maximum height. Find velocity at maximum height, velocity after 1 second of projection, change of momentum when it strike the ground, and velocity when it makes 30 degree with horizontal. So these are the question. A particle of mass 2 kg is projected at an angle 60 degree with horizontal with velocity 80 meter per second. Find velocity at maximum height, velocity after 1 second, change of momentum when it strike the ground, velocity when it makes 30 degree with horizontal, and maximum height, range. All are simple question. Just you put the formula, just you take the formula and put the result, put the information given in the question. So now we calculate this result. So given mass equal to 2 kg, angle equal to 60 degree, initial velocity at an angle 80 meter per second. So at first, when at the maximum height, velocity becomes u cos theta. So one is the result. Velocity at maximum height will be u cos theta. U cos theta means 80 cos 60 degree, that is 40 meter per second. Okay, this is one answer. Second answer, next question. Suppose velocity after 1 second. Velocity after 1 second, v, we know v equal to root over vx square plus vy square. Vx equal to u cos theta, which is 40, and vy equal to u sin theta minus gt whole square, that is u sin theta equal to 80 sin 60 degree, g equal to t is 1. So this is the result. Velocity at any velocity after 1 second. Now the velocity when it makes angle alpha, makes angle 30 degree with horizontal. We know this is the projected. Suppose this is alpha equal to 30 degree. Now vx, vy. So we take the result tan alpha, tan 30 degree equal to vy by vx. This is vy, this is vx. So vy equal to velocity when it makes 30 degree. So vy equal to now the velocity when velocity now the velocity when it makes an angle 30 degree. So suppose this angle is 30 degree and this is v, and we know the horizontal component remains same. We know the horizontal component, this and this remain same. So here u cos 60 degree and here v is unknown, v cos 30 degree. So v equal to u cos 60 degree by cos 30 degree. Now what is u 80 cos half root 3 by 2. So this is the result. Now change of momentum. Change of momentum equal to, we know formula is 2 m u sin theta. So put the result. 2 into m, 3 mass 2 kg. 2 u 80 sin 60 degree. This is the result. Now if the question is in the form a body is projected with velocity this, suppose question is in the form this, a body is projected with velocity this, that is you are given in terms of vector, no angle of projection, initial angle of projection, no initial angle of projection, and magnitude of velocity given, that is velocity is given in the form of vector. Then how can we find this result? So we know here this velocity is given in terms of u and theta. If it is in the form of vector, then this becomes u equal to this. If this velocity we express in terms of vector, then this becomes this. So now in the question it is given this, so we can equate this to this and this to this. So u cos theta will be 3 and u sin theta equal to 4. Now put the formula. Velocity after 1 second, we know velocity, the formula is u cos theta whole square plus whole square. So u cos theta is 3, u sin theta 4 minus g 10 into 1. So this is the velocity after 1 second. Find velocity at angle 45 degree. We take angle 45 degree. We know v cos 45 degree equal to u cos theta, which is equal to 3. So v equal to 3 by cos 45, 3 by cos 45 1 by root 2. Okay. Now velocity, this complete. Velocity at highest point, very easy. Velocity at highest point will be u cos theta, so 3. Second, velocity at highest point, velocity point velocity at highest point will be u cos theta, that is u cos theta equal to 3. This is the answer. Now range formula is u cos theta into time of flight. So always write the range in terms of horizontal velocity into time of flight, this form. So we can put this u cos theta equal to 3, u sin theta equal to 4, g equal to 10. This is the result. Now this is the end of the class. Students, subscribe my channel to get more video. Okay, thank you.